announcement, and if you heard the end of that last video, it sounded like I was having a bit of an episode, but I was just trying to talk over the announcements. All right, so joules per coulomb is defined as a volt. The question after I cut video was, isn't it volta, like the little info box says? Yeah, oftentimes when we have units, people will butcher the last name of the person a little bit, like amperes becomes amps. Volta gets shortened to volt, and I don't know who we want to blame for that one, but it's what happens. Okay, so why Joule gets to hold on to his whole name and Newton doesn't become the Newt, I have no idea. But I don't control these things. I just play in this world. I don't make up the rules. All right, so we got joules per coulomb, and actually, you know what? I feel like I want to write this again and just say that there's this thing called V that's calculated as KQ1 over R. I'm going to put a box around this one, and I'm going to put a box around this one. And I want to give it a name. It's not called the volt. The volt is actually a unit. It's called, the concept is called electrical potential. And I find that name annoying. Not because it's not accurate or anything like that, but I have this thing called electrical potential energy, and it is in joules. And I have this other thing called electrical potential, which is a very valid thing. We've all heard of a volt. Somebody mentioned that it's the label that we have on our wall sockets, 110, 120 volts in North America. But it's called electrical potential. It's how many joules per coulomb of electrons. It's a rate, right? So, I mean, this is kind of an annoying thing that they have similar names. If we were going to talk about an analogy, you know what, earlier on I was talking about analogies between force and energy, with electric potential energy and gravitational potential energy, gravitational force, electrostatic force. If we wanted to have an analogy with electrical potential, it would go a little something like this. We talk about, here, I'll just write the word analogy. Analogy, which is obviously the study of Anna. Analogy. Eg is negative G mm over R. If there was going to be something like a gravitational potential, not gravitational potential energy, because we've all heard of that, but if there was going to be such a thing called gravitational potential, let's just pretend that we would call it Vg, just because we don't want to make up extra letters. Let's say we call it Vg. What that would mean is I would talk about how much gravitational potential energy there is per amount of mass is present. The units of that thing would be called joules per kilogram. And, you know, I can't think of a reason why I would care to have a gravitational potential. It could be that if I had a grain elevator or a water tower, I could talk about how many joules of stored energy was in the water, in that water tower, per kilogram of water that's there by virtue of its height up in the air. And that could be a thing. I would say, oh, you know, if I have 5,000 kilograms up there, well, you know, there's 50 joules per kilogram of water up there. And then I could maybe do a little bit of math to figure out if I let that water flow like a waterfall, how much energy I would pick up from a turbine or something like that. Can you imagine what I'm talking about? That could be a thing. We don't think that way with mechanical energy. That's just not what we do with gravitational potential energy. So what I'm going to do is I'm going to put a circle around this whole thing, and then I'm going to ever so delicately put a cross through it, because we don't use that. We don't use that idea. And the fact that we don't use that idea is probably why the idea of electrical potential feels a little bit foreign to us. It seems a little bit outside of our experience. All these other things I was able to make a sweet analogy with for things that we knew about gravity and stuff, right? This one, we don't use gravitational potential as a concept. Maybe somebody does somewhere, but I don't know anybody that does, okay? But that's what it would mean. It would be the amount of joules per kilogram of stuff I've elevated up to the top of a water tower or something like that, okay? When it comes to electrical potential, do you think there could be a useful thing? I could talk about the amount of joules per coulomb of charge I've put into a battery. That's kind of like our water tower in this case. We talk about that amount of energy per charge as being almost like a stand-in for like something that could create water pressure. And when we talk about that voltage, that electric potential, we actually often do talk about that in a circuit. almost like a power cell, a battery, can deliver a certain amount of energy flow pressure, which is kind of what a volt is. And we could talk more about that idea, right? As an analogy. I'm going to pause there.